let's combine everything we've done so far into a graph. First, we'll find the x and y intercepts and plot them. Recognize that we can look at this and immediately know the x-intercepts. The factors there will generate x-intercepts of 0, 1, and 3. To find the y-intercept, we can set all of the x's equal to 0. Since one of the x-intercepts is already 0, we know the y-intercept has to be 0. Next, we'll determine end behavior. To determine end behavior, we first look at the degree. We can see that the degree is 3, 4, 5, 6, which is even. That tells us the same direction. Either they're both pointing up or both ends are pointing down. To know which is which, we then look at the leading coefficient, which in this case is 1. So a sub n is 1. That is a positive number, which means both ends point up. So we know this end's going to point up, and this end will also point up. Next, we'll look at multiplicity and see what happens there. So let's look at the zeros and their corresponding multiplicity. The first 0 that we have is 0. The first x-intercept is 0, which is generated by this factor. Its multiplicity is 2. The next 0 on our graph is 1, generated by this factor. Its multiplicity is 1 because of the power there. The next 0 we have is 3, generated by this factor. Its multiplicity is 3. So let's go through and see what's happening at each of these x-intercepts. At 0, we have a multiplicity of 2, which is even. That means the graph is going to touch and turn around at that point. So the graph is going to bounce off and turn around at that x-intercept. 1, this x-intercept has a multiplicity of 1, which is odd. That means the graph is going to cut across. It's going to go through this x-intercept. Crosses the x-axis. And then 3 has odd multiplicity, which means this one will also cross the x-axis. Now we just need to connect what we have. So we'll connect this piece, and then the other end we can connect. And then we have to do a little bit of guessing here. There is some extra work we can do, but all we're going for is a very rough sketch. We know this eventually has to turn around, giving us a local max, and this down here will eventually have to turn around, giving us a local min. But we're just going for a quick approximation, so we'll just sketch that and indicate the max and the min. And we have a very, very rough sketch of this graph. It's not super accurate, but the general shape of this is incredibly close to the actual graph. And see how close we are? We have x squared times x minus 1 times x minus 3 raised to the third power. I'm going to standardize my zoom so we can zoom out a little bit. And notice it's not perfect, but it's pretty close. We have a very rough sketch. Notice the end behaviors are good. We have a local max and a local min. Their min is a little bit lower than the min we have, but that's okay. We're going for just a very rough sketch. And in general, this shape is very close to this shape. In this example, we'll start by finding the x-intercepts. We can find those by quickly looking at these factors. The first factor tells us that the first x-intercept is 0. this factor, if we set it equal to 0 and solved, we would see that the x-intercept is 4. And then this one, if we set this factor equal to 0 and solve, we would see that this x-intercept is -2. To find the y-intercept, we set x equal to 0, or we could recognize that we actually already have the y-intercept. It's 0. To determine end behavior, we need to do a couple things. We need to first look for the degree. The degree in this case, if we'll add these powers, we get 2, 5, 6, 7, which is odd. That tells us opposite directions. One end is pointing up and one end is pointing down. We will not know which is which until we look at a sub n, which is -3. The leading coefficient is -3. And since it's negative, that means overall it's decreasing. So it's going to start pointing up on the left, but eventually it's going to start pointing down. Next, we'll look at multiplicity. So we'll identify the zeros, which we found to be -2, 0, and 4. And we'll also then talk about their multiplicity. The multiplicity of -2. First of all, -2 is coming from this factor, which has a power of 2, which means the multiplicity is 2. The 0 is coming from this factor, which has a multiplicity of 2. And then 4 is generated by this factor, which has a multiplicity of 3. Remember, even multiplicity means it's going to touch and turn around. Odd multiplicity means it's going to cross. So -2, this x-intercept has a multiplicity of 2, which is even. That means at this point, the graph is going to touch and bounce off. It turns around. 0 has a multiplicity of 2. So again, this one is going to touch and turn around, bounces off at that x-intercept. And then 4 has a multiplicity of 3, which means at 4, since the multiplicity is odd, the graph is going to cross the x-axis. From here, we just need to connect the end behavior to what we have for our sketch. And it looks like we have a local max between -2 and 0, and another local max between 0 and 4. And again, we're going for a very rough sketch. If we wanted to know how high these actually go, we would have to do some more work. We don't need to do that for just a very rough sketch. So in the calculator, we'll type in -3x² times x minus 4 cubed times x plus 2 squared. And looking at the graph, we get something kind of weird happening, and that's just due to the zoom. It happens that these peaks are like pretty far up there. So if we use our window to zoom out a little bit, we can change the Y max. Let's change it to 500 to see what happens. And so we can see the first local max, but we don't see the second one. So let's change that window again. Let's maybe make it 2000. And finally we can see it. So again, our graph is somewhat close, right? We have end behavior looks good. We do have 2 local maxes in our sketch, but the peaks, the actual value of those max values, we didn't get very accurate. But again, that's okay. We just want a very rough sketch for now. In the final graph, we will start by finding the x and y intercepts. Again, the x-intercepts are fairly easy. We have 3 and -1. This time we don't have 0 as our x-intercept because there is no x beside the 2. Whereas in the previous examples there was an x beside that number. That means we have to do a little bit of work also to find the y-intercept. To find the y-intercept, recall that we make the x's 0. So we have 2 times 9 times 1, which is 18. So again, we're just going to approximate where that is up here, y-intercept of 18. For end behavior, we need to first find the degree. If we add these powers, we have 3, 4, 5. That's a 5th degree polynomial. That's an odd degree, which means opposite things are happening. When one end points up, one end points down. To determine which is which, we'll look at a sub n. A sub n is 2, which is positive. That means that this is increasing overall. Next, we'll look at multiplicity. The zeros, or x-intercepts, are -1 and 3. And we'll look at their multiplicity. -1 is generated by this factor, which has a multiplicity of 3. And then the 0 of 3 is generated by this factor, which has a multiplicity of 2. So in behavior, we know that overall it's increasing. It's dropping down at first, but in the end, it starts pointing up. Notice the multiplicity on -1 is odd. That means it's going to cross at -1. Then the multiplicity of 3 is even, which means at 3, the graph is going to touch and turn around. So finally we can just connect these in behavior, and then -1 is going to come up to 18. There's going to be a max somewhere. Again, we're just approximating where that max is, and then it has to come back down to bounce off the 3. Again, if we wanted a more accurate graph, we could always throw it into the calculator. 2 times x minus 3 squared times x plus 1 raised to the 3rd. I'm going to zoom 6 to go back to the standard window. Again, I'm going to have to change my height though, so window, let's make the y max, let's say 500 again. We'll start there and see what happens. And it looks like we have, again, a very rough sketch, but it looks pretty good. It's dropping down on the left, we have a peak, bounces off at 3, and then shoots up forever.